Good evening, one and all. In today's lecture, we will revise one-dimensional arrays first, which you have already seen in the recorded videos, and then we will start with two-dimensional arrays. So we have seen the classification of data structures, that they are primitive and non-primitive. In non-primitive, they can be linear or non-linear. Linear means one after the other. In non-linear, you can have many successors and predecessors. Means before your element, you can have many elements, and after your element, you can have many other elements. But in linear data structures, one after the other. Then array is a collection of elements which are of the same data type. In Python, you can have different data types within the single list or single array. But in C language, C++, Java, you need to have homogeneous arrays, that is, same type of data in the entire array. So this is the representation of arrays. One after the other, the elements are arranged. The index of the first element is 0. So you can access the element 40 using the index 0. And so on, you can go up till n minus 1. So if there are 9 elements, the last index will be 9 minus 1 equal to 8. If there are 10 elements, the last element's index will be 9. Then this is an example of declaration as well as initialization of an array. This one. So int ARR of 6. 6 means you can store 6 elements in your array. So I have stored 6. So index will be from 0, 1, 2, 3, 4, and 5. That is 6 minus 1 is the last index. We have seen how to calculate the address of a element in an array. That is, if you want to find the address of the element, suppose the third index element, that is, this is index 0, this is index 1, this is index 2, this is index 3. So you want to find the location of the third index element. So you want to find the location of 7. So base address, that is the starting address of array. Starting address of array means address of the first element of the array, which is 100. It will be given in the question. Plus this 2 means how much size the data type of the array occupies. Data type of array is what over here? Can you tell me?
Integer.
Yes. So yeah.
Integer.
Yes. So integer. In some compilers, it will occupy 2 bytes. In some, it will occupy 4 bytes. So here it is suppose occupying 2 bytes. So 2 into the element size is 2 into the just a minute, element size is 2, and suppose the index should be 3 over here. Actually, it's just a mistake. Okay, I'll show you one more example. And we have seen here the array declaration. That is, you know this, if you don't initialize then garbage values, you can initialize it. You can initialize with the same elements. Then if you just give your curly braces for the size 3, that means 3 zeros will be stored in memory. If you write a single 0 means this is your first element and these two are by default 0. Okay, you have already seen this. And if it is 3 and you're specifying, means you can specify 3 elements, but you've specified only one element in your curly bracket. So the first element will be what you've specified, and by default others will be 0. So now, have you understood all this up to the recorded videos and this revision? Have you understood? Yes?
Yes.
Okay. Others?
Yes.
Yeah.
Okay. Okay. So now we are starting with two-dimensional arrays. Now you might have also seen in Python two-dimensional lists for those who are from divisions A, B, C, and D of first year. And currently you are studying also literal collections in Python. So it is similar to that. There also you can have a list within a list, that is called nested list. Here also you can have one array within another array. So inside one array you can have another array. So here there are two arrays. Okay, there's an outer array, and inside you can have inner arrays. So two arrays, so two dimensional. Okay, we'll see an example now. A two-dimensional array is a collection of elements in rows and columns. So your matrices, that is, for example, this way, you can have elements in your matrix. Okay, so you can represent matrix with the help of 2D arrays. The syntax is you have to use two indexes here, or two indices, two subscripts. Okay, index is also known as subscript. That means if I say a of 0, means 0 is the index of the first element of the array. If I say a of 1, 1 is the index of the second element of the array. If I say a of 3, it is the index of the fourth element of the array. Okay, index is always less than the actual position of the element. So two subscripts you have to use. The, yes, any doubt?
No.
Okay. So data, now this is the syntax of two-dimensional arrays. It is similar to one-dimensional arrays. What part is common is data type, suppose integer. Then you can specify the name of the array. You can give any name. Then you used to put square bracket, and within that you used to write the total number of elements that you can store. Suppose you can store 5 elements. So now in two-dimensional arrays, you have to put two square brackets, and inside the second bracket also you can put some number. Now this indicates what? Whatever is within the first square bracket is the total number of rows in your 2D array. And whatever is in the second square bracket is the total number of columns in your 2D array. So see our example, integer array with the name num. 3 rows can be there in this array, and there can be 2 columns. Okay, so there are two ways of initializing. One is like your linear normal array, and the other type is a little different. So we know that there are 3 rows. Okay, so let me show you. See here, suppose there are this is my array. Okay, int num 3 comma 3 and 2. So there should be 3 rows. Okay, so see here, the row is what? See at the right side of the screen, you can have first row, second row, third row. Okay, horizontal, whatever I've put the arrows, that is called a row. And 2 columns. Okay, so 2 columns means vertical. Whatever is vertical is your column. So 3 rows means these horizontal, and 2 columns means 2 verticals. Now, if I am saying I have to put curly bracket, okay, for my linear array, and then within that again curly brackets have to be there. Now, if I write within the first inner curly bracket, I've written 4 comma 3. So that is my first row, as you can see here. Okay, 4 comma 3 is my first row. Then put a comma, again curly bracket open and close, and inside that 5 comma 6. So 5 comma 6 is my second row. Then 8 comma 9 is my third row. Okay, this is the way, means your inner array represents each row. Okay, so if I have an array and within that I have another array, that inner array is nothing but one row, and I can have multiple rows, so multiple curly brackets within outer curly brackets. Have you understood this?
Yes.
Okay, now that's what I've written here, that integer is the data type, num is the array name, number of rows, number of columns, and these are your actual values. So how we can number the rows? We know that there are 3 rows. The row starts from 0, next row will be at 1, and next row will be at 2. Okay, so a of 0 is first row. Similarly, even your columns, first column is column 0, second column is column 1. Okay, just like how your index goes up to n minus 1. So you can represent this as what? If your element is over here, okay, so it is row number 0 and column number 0. So you must write A of row 0 and column 0. Okay, similarly, in your 0th row, but first column means row number is 0, column number is 1. So A of 0, 1. Similarly, first row, 0th column. First row, first column. Second row, 0th column, and second row, first column. Okay, it means you can have different combinations of row index and column index. Have you understood this?
Yes.
Yes.
Yes. Okay. So this is again a bigger 2D array in which the index goes from 0 to n minus 1 for rows, and also columns are from 0 to n minus 1. So here first row is at index 0, then 1, then 2, and so on up to n minus 1. Similarly columns. So you can have in within the first row means what? Your row index will be same. It will be 0 only. But what are the different columns? 0, 1, 2, 3, 4 up to n minus 1. Next, for your first row, that is this second block, row index will be 1 only. But what are the different columns? 0 to 1 to 2 to 3 and so on up to n minus 1. Okay, similarly, you will start your first element at 0 comma 0. Okay, a of 0, 0. And last element will be what? A of n minus 1, n minus 1. Do you agree with me?
Yes.
Yeah.
Yes.
Okay. So suppose it is a 3 row and 2 column. Then maximum index is, there are total 3 rows. So row will go from 0, 1 and 2. Okay. And if there are 2 columns, then it will be 0 and 1. Okay. You know this. Then how to represent this in memory? Now remember that your memory in the computer is not in the form of a table. Okay, this we are representing in the form of a table because it is possible to print it like that on the screen. But it is not possible to store it as a table in memory. We have to store it linearly only, just like our one-dimensional array. So there are two possible ways. One is row major arrangement and other is column major arrangement. This is because the memory of your computer is linear only. You can store the elements one after the other in your memory. So how you will store a two-dimensional or multi-dimensional array is, you have to first store first row, then second row, then third row, and so on. That means row by row you are storing. So you are first storing 0th row, that is 4, 3. Then in row 1 we have 5, 6, and row 2 we have 8, 9. So linearly row wise we are arranging. Similarly, column major might be what? Column wise you are arranging. Means first column has what? 4, 5, 8. So that is placed here. Okay, 4, 5, 8. Next column has 3, 6, 9. So that is placed next. Similarly, you can have multiple columns. So you can arrange row wise. That means horizontal blocks are placed in memory. If you are arranging column wise means vertical blocks are placed in memory. Have you understood row and column major?
Yes.
Yes. Okay. Should I repeat or others also have understood? I can hear only one response. Have others understood?
Yes.
Okay. So we can access any element of an array if we know its base address. Is it possible? Because we have seen how to calculate address of the other elements using the base address. If you know base address, by certain multiplication, you can find out the remaining address of the remaining elements of the array. So see here, how to calculate that in 2D arrays. You have seen that in 1D arrays, okay? Now assume that when I write int a 3 and 2, and 3 means total number of rows, 2 means total number of columns. Now suppose I want to print the value using printf. I want to print the value of a of 0, 1. Okay, so here whatever I write in my square brackets doesn't mean it is the total number of rows or columns. Okay, if I want to access any element, I have to use the same syntax, but it doesn't mean whatever I'm writing in the square brackets is the total number of rows and total number of columns. In your initialization or declaration, that time whatever you write in your square brackets is total number of rows, total number of columns. But suppose if I want to print the value of a01, that means my zeroth row and my first column. That element, if I want to access, I have to write a within square bracket 0 and within square bracket 1. So this is the difference between your initialization part and your accessing part. So here suppose that for any array A of mn, here m is total number of rows, n is total number of columns. Okay, m is number of rows, n is number of columns. And I want to access the element at index I and j. That means I is the row index, j is the column index. Okay, whatever index you specify first, it is row index. Whatever you specify next is your column index. Means A, I, j means I is row, j is column. I cannot be column here, j cannot be row here. I is always row and j is always column. Okay, means if you write I and j, if you write j and I, then definitely j is row and I is column. Means whatever you write first is row, irrespective of what variable you are using. Okay, you can use I, j, a, b, c, d, whatever. But whatever you write first is row and whatever you write second is column. So how to calculate the address in row major and column major? This is the formula. Base address plus if it is row major plus column index into number of rows plus row index into element size. When we see an example, you will understand. See here, the question is find the location of element 8. Then should not be written. Element 8 in an array 3 2. The address of the element would be 2 0. Means what we understand from here, if I'm saying a 3 2, okay, this is my array. Here 3 and 2 is your total number of rows and total number of columns. So let me write here, rows is equal to 3 and columns is equal to 2. But I want to find the element at 2 0. So my I is equal to 2 and my j is equal to 0. Okay, have you understood this or should I repeat? Have you understood?
Please repeat once.
Okay. See, we have to find the location of element 8 in an array. Okay, not then. In an array. This is my given array. A of 3, 2. Means what? This is the total number of rows and columns is mentioned in this. And I have to find the address of the element which is at A20. Okay, means my array has total number of rows 3, total number of columns 2. And I have to access the element at 20. Okay, so the number of rows, that is R, is equal to 3. Number of columns is C, that is equal to 2. And I have to access the element at 20. Means my index which I'm interested in, it has two parts, right? Row index and column index. So I want the row index to be 2 and column index to be 0. And this element I want to access. Means here we were right.
Okay.
That,
Okay.
yeah, in this table, see, what is the size? Suppose it is arrays 3 rows and 2 columns. Then within that you can have different combination of index and column, right? So that is what we want to access. Is it clear?
Yes.
Yeah. We will see an example now. It will be even more clear. So formula in row major is, means row wise if you are storing your elements, base address. Here it is given as, it is not mentioned in the question because I forgot to write it, but it is 502. Okay, it will always be given because without that it is not possible. Here is the base address is 502 plus within brackets column index, means the element which I'm interested, that ka column index. I am interested in the element a of 2 of 0. Okay, what is the column index of a of 2 of 0? Can you tell me?
0.
Yes, it is 0 into the number of rows. Number of rows is what? Total number of
3.
rows, it means. Yeah,
2.
3. It's 3. total number of rows,
Like three,
not,
three. Yes.
yeah, not the element ka row index. I'm telling about the total number of rows, that is 3. And then plus row index, that is your 2, means the element which you're interested in, row index, that row index, into the size of your elements. Okay, so just a minute. Okay, the example is not matching. I'll show you on Notepad. Okay, I have to correct some things in this PPT. See here, int a of 3, 2 means number of rows. Okay, this will be clear now. Number of rows is 3. Let me write number of rows is 3 and number of columns is 2. Okay, and I want to print the element. Suppose consider I want to print the element. Okay, print the element 2, 0. So here, okay, suppose in printing, then my row index is 2, it is I, and what is my column index? Can you tell me?
Two.
Yes, column index is 0. Whatever you write first is your row index. Whatever you write second is your column index, right? And I'm telling column index, not total number of columns. Okay, if I say total number of columns, it is whatever is your initialization, that part. Total number of columns is 2. If I say column index of an element, then it is this one what I'm talking about. Have you understood?
Yes.
Yes.
Yeah. And column index of element. If I say column index of an element, means how you'll access it, that index I'm asking about. And if I say total number of rows, that is what in your initialization part. So here we know what is the value of total number of rows, total number of columns. I'm interested in the element a of 2 of 0, that is row index 2, column index 0. Now in row major, the formula is base address. Okay, look at your left and right both. Okay, the formula is at the left hand side. I'm implementing substituting on the right hand side. Base address 502, it is given, plus column index. What is the column index of the element?
Zero.
Yes, it is
0.
0. Yeah, into the number of rows. What is the number of rows?
Three.
3.
Yes, it is
3.
3. Yeah. Then in the formula, I have to add row index. What is the row index of the element which I'm interested in?
Two.
2.
Yes.
2.
Yes, it is 2 into element size. Suppose integer is occupying 2 bytes, then 2. Okay, now just simply perform your operation. Whatever is in the bracket, just like mathematics will be solved first. Multiplication has been higher precedence than addition. So 0 into 3, 0. 0 plus 2, 2. Then 2 into 2, 4. And 502 plus 4. 502 plus 4 is equal to 506. Okay, this is the address of the element a of 2 of 0 in your two-dimensional array. Have you understood this?
Yes.
Yes. Now we can solve
Yes.
similarly, yes, for column major also. Okay. So for the same example, if I substitute in column major, okay, there are certain changes. Base address is the same thing. Now here you have to consider row index, that is 2 into number of columns. Okay, row index into number of columns 2. Why we are considering number of columns? Because it is column major. plus the column index, that is 2, into, suppose integers, so 2. So 2 twos are 4. Okay, I'll repeat: base address, then row index 2, then number of columns 2, then column index is, why didn't you all correct me? It is 0. Okay, you have to pay attention when I'm writing the values. It is 0, column index, into size of element. Then 502 plus 2 into 2, 4 plus 0, 4 into 2, 8. So 8 plus 502, that is 510. So this is the location address of the location of number of element of a of 2 of 0. Okay, a of 2 of 0, this element is stored at the location whose address is 510. So actually the examples have got switched. This is for row major, previous also column major. So what I've shown on notepad here is correct. Have you understood this memory representation?
Yes.
Yes.
Okay.
Yes.
Yeah. Now similarly, you can have multi-dimensional arrays. Okay, so we'll see the theory part of this in next lecture. Now we'll implement some programs. Okay, here also you can calculate address and all of the multi-dimensional arrays, means where the dimensions are not only 2. Means what? You don't have only row and column. In two-dimensional arrays you have rows and columns, but in multi-dimensional arrays you can have more than that. Not only rows and columns, you can have along z-axis, x-axis, y-axis, and all that also. So now for the programming part of today's session, see, we know how to traverse an array. That means we know how to access each element of an array. We can do it one by one by writing for linear array. Okay, this is example of linear array. If I want to access the element 2, then how should I access it? Can you tell me what should I write? Do you remember? You must write array name within square brackets. What is the index of 2? Can you tell me?
1.
Yes, it is 1. So ARR of 1, if you write, you will be able to access the element 2. So now if you want to access the element 3, what you'll write?
2.
ARR of 2, yes. If you want to access element 5, what will be the
0.
writing?
0.
0.
Yes, yeah, yes, ARR of 0. So if you want to go one by one, you can write like this: ARR of 0, ARR of 1, of 2, of 3. But if you want to use it in a for loop, okay, so that same thing will be executed again and again with some modification. You don't have to write again and again a of I, a of I. So here I will start at 0 because that is the base allocation or index. Each array element will start from index 0 up to n minus 1. So I will go from 0 up to n minus 1. Here, how many elements I have stored? Here I have stored 4 elements, but I can store how many elements here? How do I know how many elements I can store here maximum?
5.
5.
Yeah, it is by your initialization. That is, if you write here 5, means I can store total 5 elements. But as you know, if I store lesser elements, then the remaining what I have not stored, by default it is which number? Can you tell me?
0.
0.
Yes, it is 0. Very good. So here the elements which are stored in memory are 5, 2, 3, 1, 0. Okay. So my index will go from 0 up to 5 minus 1. Okay, there are total 5 elements. Index will go up to 5 minus 1. That is 4. So I less than 5 means maximum value of I that is acceptable is 4. 0, 1, 2, 3, 4. And that time, whatever is I, that is my index. So I can write ARR of I. And suppose I want to print this ARR of I must use which statement?
%p.
Yeah, %d. But what? Scanf, printf, what I have to use?
Printf.
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 Yes. Yes. Printf, and as you said, %d, and write the ARR of 0, ARR of I. So first I is equal to 0, so it will print A of 0, that is 5. Then I will be incremented, I becomes 1, then A of 1 will get printed. Then A of 2, A of 3, A of 4. Will A of 5 get printed?
No.
Okay. Any other answer? So you're
Zero.
right. No. You can not print A of 5. Why can you not print? Because I is going from 0 to 4 maximum. Okay, so 0, 1, 2, 3, 4. I cannot become 5 because I is always less than 5. So maximum ARR of 4 it can go up to. Have you understood this?
Yes.
Yeah. So let me run this program and show you. This I've executed in the videos also. Here, the elements were 5, 2, 3, 1, 0. 5, 2, 3, 1, and last element by default is 0. Okay, and this printf statement, if you comment it out, it won't come. So now how to calculate the sum of these elements? You have to do sum plus equal to A of I. If you want to calculate product, product plus equal to A of I means product and sum are nothing but another variable in which you will store the total sum. So sum is equal to sum plus ARR of I, or you can do sum plus equal to ARR of I. So what will happen here? Let me show you. So as you can see here, first time I is equal to 0. That time which element I can access, can you tell me?
5.
Yes,
Five.
I can access the element 5. So initially sum I have initialized to 0, means first time when you run inside the loop, sum is equal to 0. Then sum will become sum plus A of what?
Zero.
I.
0.
मतलब.
Yeah. Yes, I is equal to 0, so A of 0. So A of 0, because first time I is 0. So then what is the current value of sum? Can you tell me?
5.
No, I have not.
0.
Zero.
Current value 0. I have not yet added anything. So current value is 0 plus A of 0 is 5. So now 0 plus 5, sum is equal to 5. So this is the recent value of sum. Now when I'm doing next iteration, I will become what? 1. So I is equal to 1. And what is my sum now? Sum is equal to 5. So now if I do sum is equal to sum plus A of I, now I is equal to what? 1. So A of 1. So current value of sum is 5 plus A of 1 is what? 2.
2.
Yeah. So 5 plus 2, 7. So what has happened now? Your first element 5, that is here in place of sum, and your second element is A of 1, that is 2. So apparently you have stored the sum of first two elements, that is 5 plus 2, 7. Now let us go further. Now I will become what? 2 by incrementing. Then sum is equal to what? Current value is 7. Now I can do sum plus equal to. Plus equal to means sum is equal to sum plus ARR, or A of what?
2.
Yes, A of 2. What is my current value of sum? 7. 7 plus A of 2 is 3. So 3 plus 7, that is 10. So what you can observe here, 7 is nothing but from your previous thing 5 plus 2. So let me replace 7 here by 5 plus 2. And now you have added 3. So as you can see, first element plus second element plus third element and so on up to I equal to 4. Okay, so actually what you're doing, one by one you're storing the sum of the elements in the variable sum. Have you understood this much?
Yes.
Yes or no?
Yes.
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 Screen is visible. Screen is not visible. Just try to pin the account to this presentation. Okay, there are two here. One is the name and one is my presentation. Pin to presentation, this one. Okay, is it visible? Screen is still visible, right?
Yes.
Yes.
Okay, yeah. So we have seen how to access each element and find out the total sum of the elements of an array. Now, if you want to find the product, what change you will have to make?
Multiplication in plus of addition.
Yes, very good, excellent. Similarly, division, whatever you want to perform, you can perform. So this was for linear array, which I've discussed in my previous videos also. And we have seen how to accept the values also of the array. Can you accept the means here what I've done? I've initialized the array directly, like ARR of 5 is equal to within curly brackets 5, 2, 3, 1. I have initialized it. But what if the user wants to enter the values? How is that possible? Can you tell me in your own words if whatever you
Scanf.
remember? Yes, scanf and
Scanf,
yes,
and then percent d
yes,
in commas, and
yes,
then in inverted commas,
yes.
and then we'll left the space for it. Ampersand the variable name.
Yeah, and here variable is a of
Array.
index. Yeah. So here only once you'll have to write scanf to accept 5 elements, or you have to use some other logic. See, suppose I want to access 5 elements. Yes, you can tell me. See, suppose I want to
Can
access.
we
Yes,
write 5 times ampersand a or the variable name 5 times ampersand?
yes, you can do that. That is one of the possible way that you are saying that scanf, and then how many times percent d you want to accept 5 elements, so 5 times percent d, and between your percent d, which is within your quotation marks, so 5 times, let me write percent d, and never give a comma between your percent d. Okay, and only after the quotation is complete, comma, ampersand a of 0, comma, ampersand a of 1, comma, ampersand a of 2. So 0, 1, 2, 3, 4. These are the possible index I can write here. Okay, I will
We,
write here. Okay, but this is
we
not.
can use under for loop.
Yes, that is what I'm expecting, because this is not efficient, right? If you want to accept 100 elements, then 100 times percent d, 100 times ampersand. Is this efficient? No. So what, this is a repeating statement. Okay, again and again you want to access. So why not put it in a looping statement? So within my for loop, I must write scanf. Only once write percent d. I will show you how this works. And then ampersand ARR of I. So the
I.
I value will go from 0 to 4. So you can access A of 0, A of 1, A of 2, A of 3, A of 4. Okay, so it is repeating, and you have to just write it only once. You access first element, repeat the loop. Access second element, repeat the loop. Access third element, repeat the loop. So let me run this. So I'll remove the initialization. This much part is declaration. So when I run this, now user will just see a blank screen. So he doesn't know what he has to do. Okay, means the programmer has written the program, but the user will use the program. Okay, ideally means the customer will use whatever you have developed. So how will he know what he has to do? Do you have any
Printf.
suggestion? Yeah, in printf,
Printf.
what? Yes, what should I write in printf? You can write anything like enter the element of an array or enter a number. Okay, anything you can write. So if I write the printf once, I can say enter 5 elements. Either I can do this, or a better means how it will happen is I'll run this first and show you. So it is coming enter 5 elements. Then I enter 3. Either you can give space, next number, space, next number, space, next number, space, next number. So I've entered 5 elements and then click enter and it is stored in the array. Okay. Or what you can do, another way is enter 5 elements. I'll enter first element, press enter. Next element, press enter. Next element, press enter. Next element, press enter. Next element, press enter. Okay. 5 elements have been stored. Okay. So either give space between your numbers or one below the other also. Now, I don't know, means I know that it is stored in the array, but how will the customer know? He can know it by giving another guiding message, that is 5 elements have been stored. Okay, I can write like this some message, 5 elements have been stored. Okay, so the customer is not in any doubt that whether whatever I have entered is stored or not. So here it is a efficient program. I can enter my 5 elements and then I write 5 elements have been stored. Now there's another better way that you can do, so that the user knows that how many elements. Okay, otherwise you'll simply keep typing the elements and it will simply cause overflow. Means what? I can store 5 elements, but I'm storing more than that. So in order to avoid that, what I'll do, within my for loop I will write enter the element, and since there are multiple statements under my for, I should write them within curly bracket. A single statement without curly bracket is okay within for or while or if or else. So now how it will run? Can you guess how it will run? What should be the output?
Five times enter the element.
Yes. So will all the enter the element statements be printed one after the other, or how will it be?
After every time, it would show the message
New
enter the
line.
element.
Yes. So once
Every
it
new
will,
line.
yes. So once it will display enter the element, then I will enter the element. Second time it will display enter the element, then I will enter the element. Okay. So let me run and show you. Enter the element. I entered. I click enter. Again, it is telling me enter the element. So I know how many elements to enter. Now another better way, enter the or enter element
Ampersand.
percent. Within your printf there is no ampersand, right? Percent d, and then here I will write I. So what will happen? It will tell me enter the element 1. Will it tell me enter the element 1 or will it tell me something else? What is the
Zero.
first value of I?
Initially,
0.
the I
So
value
I
is
yeah,
plus
0.
one.
yeah. So you should use I plus 1. So enter the element 0 will come, but like while counting we start from 1, no, usually index is starting from 0, but for the customer who doesn't know how arrays work, he will know if we write I plus 1. So I is equal to 0, enter the element 0 plus 1 equal to 1. So it will come enter the element 1. Then enter the element 1 plus 1, that is enter the element 2. Okay, so let me run and show you. Enter the element 1. I entered it. But another drawback is what? I'm getting it as 13. Okay, while reading, it may be so that the user is reading it as 13. So what I can do, I can give a colon over here. So what will happen? Enter the element 1 space colon space. Okay, so it is better readable. Enter the element 1, I enter 12. Enter the element 2, enter the element 3, enter the element, you can enter negative numbers also. Enter the element, okay. So this way it is easier for the customer to enter the numbers. Have you understood this?
Yes.
Okay.
Yes.
Yes.
Yeah, very good. So this is how I can accept the elements. Now, as I'm accepting, one more thing I can do, I can calculate the sum plus equal to ARR of I. So what will happen? Enter the element 1, I enter it. Then it will become sum is equal to sum plus element. That is sum is equal to 0 plus element. So first element will be stored in sum. Okay, means I'm not, if I don't write printf scanf, this is the program which we saw just before this one, right? Before some minutes, we saw this program, how to calculate sum of elements. But as I'm accepting the values, I'm calculating the sum. Is it possible?
Yes.
Yes, it is possible. So let us see how it works. Let me write %d. Yeah, and sum is initialized to 0 in the beginning. Yeah. So enter 5 elements. Enter the element 1. Enter the element 2, 3, 4, 5. So 5 elements have been stored is the prompt or the message, and the sum of elements is 173. You can add this and check later. Okay, so we have seen that as we accept the numbers, we can calculate the sum. If we want to first accept and then we want to calculate the sum, how many for loops we will need? Two for loops, right? One for loop to accept the numbers, and then we want to, after accepting all the numbers, we want to find the sum. So to find the sum, you'll need another for loop. Am I right? Yes. I'm saying if I want to perform these operations separately, first I want to accept everything and then I want to find the sum. Is it possible?
You can do, but you need another for loop.
Yeah, that's what I'm saying. I'm asking how many for loops you will need. So you should have said two for loops. Yeah. So you can do it and you'll need another for loop. Similarly for product, if you want to do separately as it is, two for loops. Now, how you can accept a 2D array. Now, you have row index and column index. Okay, so one for loop will be for your rows and your next for loop will be for your columns. Okay, so two for loops every time for your matrix or 2D array or for your table. Okay, you can call matrix and table the same thing. So you'll need two for loops. Suppose there are 3 dimensions in your array, means what? You'll need three for loops. If there are 4 dimensions in your array, that means 4D array, you need four for loops. If I have 1D array, I need one for loop. 2D arrays, two for loops. If I have 100D array, how many for loops?
100.
Yeah.
100.
So number of dimensions, those many number of for loops or while loops. Instead of for loop, you can use while loop also, do while loop also. Okay. So to accept a 2D array, you need two for loops. So now pay attention how this will work. I am accepting the number using scanf. And same thing, enter the number. Here what I'm doing, enter a of %d of %d. So in place of %d, the row index, that is I value, and the column index, that is j value. Okay, we'll see how it will execute. So this is a two-dimensional array. Why? Because there is two subscripts or two index values that are specified. That is 3 and 3. That means 3 rows, 3 columns. That means two subscripts. That means two-dimensional array. Now, carefully, we will trace the for loop. So see, in the beginning, what is the value of I? Can you see the program and tell me?
0.
Yes, it is 0. Now, because here, okay, I've declared I here, but I've initialized it in my for loop. I is equal to 0. So whatever is inside this outer for loop, this is my outer for loop, inside that inner for loop. What is this called as? Nested loop. Okay. So when I is equal to 0, this whatever is inside this inner for loop will get executed. When I is equal to 1, again the inner for loop will get executed. I is equal to 2, again the inner for loop will get executed. Okay. You know this. So when I is equal to 0, my inner for loop will get executed first time. What is the value of j? Can you tell me?
0.
Yes. So when I is 0, j is also 0 for the first time. when j is 0, what will happen? Inner for loop, the statements of inner for loop will get executed. What is it? Print f, enter a of, and it will enter the inner for loop and it will say enter a of %d and a of %d. This %d will be replaced with which value? Can you tell me?
I.
Yeah, and
I.
the second %d with j. So what happens? Here I will get it as enter a of 0, 0, means first element. Have you understood this? How the output will come or no? See, whatever I write in printf is just a statement. Here, if I write a of anything, it is just like a statement. It doesn't mean syntax. Okay. See, I'll run this program and show you so that you have a better idea. See what it is saying for the first time. I is 0, j is 0. So it is telling me enter a of 0, 0. Now have you understood?
Yes.
Yes.
Yeah, I hope so. Now, so I is 0, that time what? J is 0. Then I will accept my first element and I'll accept it. Okay. Then the inner loop will get incremented, right? Everything of the inner loop, how many iterations? 0, 1, 2. So then what will happen? I is 0 and then j becomes 1. Again, I'll accept the element. Then again, j becomes 2. Okay. Now j maximum can be 2 over here because j is less than 3. Okay. So then inner for loop is completely over. Now outer for loop will get incremented. I was 0, then I will become what? 1. So I is equal to 1. Again, the inner for loop for same values of j, that is 0, 1, and 2. Okay, then inner for loop is again over. Then I will become 2. Again, these three things will happen for j. 3 times inner loop will run. Then what will happen? I maximum index which is allowed is 2, 0, 1, 2. Okay, so finally both the for loops are terminated. Have you understood this?
Yes.
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 Are you sure? Then I have accepted the elements. Now if I want to print the elements, for printing also I'll need two for loops, right? Because I have to print row index and column index. For the row index and column index, for matrix, you will need two for loops. Am I right?
Yes.
Yeah. So again, to print, what you'll do here, simply you have to print %d arr of I of j. Okay, this is how we access an element, right? So this is your printing. You can print the elements. Okay, have you understood this? How to accept two-dimensional array? Yes or no?
Yes. But can you just repeat it once again? The
Yes,
entire.
I will. 2D array accepting that part.
Yes, only that part only.
Okay, okay. So see, suppose you had one for loop. Okay, suppose you had one for loop. When you have one for loop, I is equal to 0. That time what will happen? The statement will get executed. Okay, you have a single statement, suppose in the for loop. Then I will become 1. Then again that statement will get executed. Then I will become 2. Again that statement will get executed. The only change is, instead of that single statement, you have another for loop over here. Okay, so instead of this statement, you have to execute for loop. Instead of this statement, again inner for loop. Okay, this is what will happen. The inner for loop. Why is it inner for loop? Because it is inside the outer for loop. Again inner for loop. Again inner for loop. Okay, And how many times this will happen? Inner for loop also has to get executed, right? Outer for loop, how many times it was getting executed? For I is equal to 0, 1, 2. Similarly, inner for loop also has certain number of executions because it is a loop. Again and again, it has to get executed. How many times? For j is equal to 0, 1, 2. Okay, so when j is equal to 0, inner for loop will get executed. Then j will become 1. Again, inner for loop will get executed. J will become 2. And that is the final value of j because less than 3. Then again, what will happen? Inner for loop will execute for I is equal to 1. Inner for loop will execute for its own number of times. Okay, inner for loop also has to execute for number of times. How many times? For j is equal to 0, then for j is equal to 1, and for j is equal to 2. Okay, so inner for loop execution over. Now I will become what? 2. I was 1, I became 2. Again inner for loop. How many times inner for loop? For j is equal to 0, for j is equal to 1, and for j is equal to 2. Then what will happen? Inner for loop over, then I will become 3. But maximum value of I is up to 2. Okay, so complete for loop execution is over now. Have you understood now?
Yes.
Yes. Yes. So we can stop for today. Do you have any doubts? You can ask me now.
Can't we include a printf statement in first for loop at the time we are accepting the value?
See, if you enter only in first for loop, what will happen? You will write here, enter what? You'll means you're telling this printf statement. Why inside inner for loop? Let me write it in outer.
No, no, not that one.
Then,
The below one, the printing the element statement.
what will happen if, okay, I'll execute and show you first time what will happen. Printing the elements. If I remove this and put it here. Now when I execute this program, what will happen? When I is equal to 0, whatever is inside the outer for loop will get executed. So first it will come printing the elements, or you can say accepting the elements because we are accepting. Then what will happen? I will accept the element. Then again I will accept because j is equal to 1. Then j becomes 2, again I'll accept. Then again it will come, the statement will become what? Outer for loop will get executed. So accepting the elements. So again and again it will print accepting the elements. See here, accepting the elements, enter a of 0, 0, I entered. J is equal to 0. Now j is equal to 1. J is equal to 2. Then again outer for loop. So it will start from where? From accepting the elements. We don't want that, right? Again and again, why accepting? Once only accepting will be printed. So now I is equal to 1, as you can see here. Enter a of I equal to 1, j equal to 0. I'll enter. Then I is 1 only, but j is getting incremented. Then I is 1 only. For that I, j is getting incremented. Then again, I becomes 2, j is 0. Then I is 2, j is 1. I is 2, j is 2. So have you understood now? Your row will be same, and in that row, how many elements are there? That will get executed. Then next row, how many elements are there? Those many. So if I want to show you here, see here, in my zeroth row, how many elements are there? A of 0, 0, A of 0, 1, A of 0, 2, A of 0, and minus 1. So in my first row, I have to accept all the elements. Then next row, I have to accept all the elements. Then next row, I have to accept all the elements in that row. So have you understood this for today's?
Yes.
Yeah.
Thank you.
So yeah, welcome. Any other doubt? You can start putting your attendance, name, roll number, division in the chat box. Any doubts? And after you put your attendance, you can leave today's session. Thank you. Roll number, name, and division.
So, so what will be the timetable for your live sessions? Like everything
Yeah,
and that except topic is live, no? So regular live sessions would be there, or what?
uh, actually it is Tuesday, Thursday, and Saturday, but since yesterday it couldn't take, so today we took. So tomorrow again you'll have, because it's Thursday. So Tuesday, Thursday, and Saturday. Now since recorded videos are over, so Tuesday, Thursday, and Saturday we'll meet live,
Okay. And
6:30 to
tomorrow which
7:30.
topic?
Tomorrow this only we have to continue 2D arrays. See, now you know how to accept the array, you know how to print the array, you know how to calculate sum of elements of array, you know how to calculate product of elements of array. But what if you want to search a particular element in an array? What if you want to arrange them in ascending order, the elements? Then what if you want to uh, update the elements? You have initialized them to 2, 3, 4, 5. If you want to make that 10, 11, 12, 13. So many operations are yet to be seen. So those things we can see tomorrow.
Okay.
Yeah. Same things you can perform in Python also, which you are studying right now, and those who of you have finished studying. Any other doubt? Else we can end today's session.
Thank you.
Welcome.
Thank you.
Thank
Welcome.
you.
Welcome. Any doubts?